Everybody, welcome to WPGR 15 April 2021. Our guest tonight is Eric Mann, talking about WordPress and artificial intelligence. And we're going to let him get started. Take it away, Eric.
So welcome everybody to the 2021 Q2 earnings discussion for Cyberdyne Systems. I do have to apologize in advance, but Dr. Dyson was otherwise disposed at the moment, dealing with some incidents that happened in the lab last night. So I will be covering his executive summary for progress on our new cyber defense systems, and just want to give you a heads up that he will be checking in later next week to answer some questions for you. So over the past couple of weeks, we have deployed some very sophisticated systems to monitor various biological and organic nodes throughout the world. And you can see in real time where all of these, wait, what? Hold, that's next week? Crap, hold on, just one moment. Let's move on and talk about WordPress and AI instead, because that is a much more palatable topic than talking about everything else that you should forget from those previous slides. So welcome to this talk. We will be discussing WordPress, artificial intelligence, and machine learning. But before we dive too deeply into that, let's take a moment and talk about just what machine learning is. So machine learning, it's something that's talked about in the media quite a bit. It's something that's talked about in movies, science fiction, science fact as well. Everybody tries to make it seem like it is this incredibly sophisticated topic that requires a PhD, requires a bunch of sophisticated algorithms, acronyms no one can remember how to spell. Really, machine learning is quite simple. The concept behind machine learning and AI is to teach computers to mimic various biological mechanisms. You're teaching an inorganic machine to act like an organic machine, to act like something that we can see in nature, some sort of a physical biological analog. And to give you some examples, I want to talk about two different forms of different things that we have done in the machine learning world that help make computers smarter and help actually optimize for things. The first is something called a genetic algorithm. So this is just one example of how we can use a biological physical analog to teach computers to do something novel, something unique, and something incredibly sophisticated. In a genetic algorithm scenario, you're going to use effectively genes, so biology, how we actually use DNA to evolve and adapt new traits over time, and focus on optimizing some local maxima or local minima, finding some precise way to do a specific thing using randomness. In genetic algorithms, you start with a random population. So if you are trying to identify the best way to write a phrase, for example, you'd start with a soup of random characters. One specific scenario that genetic algorithms are used in, though, is logistics and supply chain management, where the traveling salesman problem is kind of the canonical example. In the traveling salesman problem, you have, let's say, 30 cities, and a salesman must travel to each city exactly once and then return at their starting point. And you want to find the most optimal path that salesman must travel to get from point A to B to C to D and go through the entire network of 30 cities before returning home. In a genetic algorithm approach, each city is given an identifier, and you start with a population of random paths that person can walk. So random paths the salesman can travel, visiting each city once before returning home. You then evaluate the fitness of that solution. You go through and identify how long is each path. How long will it take a salesman to travel to all 30 cities? You use this fitness, the strength, the shortness of a path, to actually reproduce and create a new population of potential candidates, of potential paths. Again, we're going with the biological analog here of genetics, where you have a population. The fittest members of that population then get to reproduce and create the next generation. But one other thing that you want to include here is mutation. So if you just use the random population and you just reproduced by creating a new population based on it, you wouldn't really get to the local maxima or local minima very quickly. So introducing mutation, randomly swapping two cities in the travel order, is a really good way to help the algorithm keep from getting stuck at one specific solution that might actually not be optimal. Genetic algorithms, again, are used for this kind of a solution to very quickly come up with not necessarily the optimal, but at least a quality solution to the problem. So for example, here's a visualization from Wikipedia showing several candidates on the left-hand side for a traveling salesman problem solution, in this case, just with 7 cities. And on the right-hand side, it is showing the current optimum, the best path that the algorithm has found so far. The advantage of this is that there is a limit to calculation, to the processor power for how we can actually calculate through brute force a solution to this problem. If you were to try to calculate exhaustively a 7-city path for a traveling salesman, it's actually pretty quick. 7 cities is not too bad, because what you have to do is calculate the distance from each point to every other point, and then effectively calculate every single potential path between those 7 cities, rank order them to find the shortest, and then pick the shortest one. For a limited, finite, small number of cities, this is relatively straightforward. As the number of cities becomes larger, this becomes very, very, very difficult. Trying to find the optimum solution to travel to all 50 state capitals in the United States, for example, it is actually impractical on modern computers, even supercomputers. And once you start dealing with situations of larger than 50 cities, so let's say 100 cities, 1,000 cities, it is not just impractical, it is actually impossible with current computers to find an exhaustive solution and find the exhaustive optimum. So instead, we use genetic algorithms to calculate an approximation. And this approximation gives us the approximate optimum solution very quickly. In some cases, it might just take a matter of minutes. Now, the traveling salesman problem is one solution that feels like a bit of a toy scenario, but again, talking in terms of logistics, supply chain management, and just anything where you have to order from point A to point B to point C, this becomes something that we need computers to do very quickly and reproducibly. Logistics is one example, perhaps routing trucks going from point A to point B. Another scenario would be setting up CNC machines or setting up the machines that drill holes for various dies. You might have 100 different holes you need to drill on a specific piece of hardware. Now, one solution might be to just drill holes numbered 1, 2, 3, 4 and go through everything. But if you can use a genetic algorithm to better optimize the path that the drill head needs to travel, you can cut down your manufacturing time, which increases your time to market. And the more devices you can ship per hour, the lower your margins, the higher your profits, and everybody's happy in business. So this is one example of a biological analog, which is machine learning. It is AI for optimizing a supply chain, optimizing how we actually drill holes, route trucks, or have salesmen travel. Another example, which is my personal favorite, is ant colony optimization. Again, taking a very biological analog, but this is different from genetic algorithms. So in an ant colony optimization or an ant colony simulation, you will start by dropping an ant at a random point. Think through the traveling salesman problem once again. Your ant starts at city A, and then you have it randomly move through all of the different cities by rating each city based on its attractiveness to be the next city it travels through. Each city is given a certain attractiveness value based on the distance between where the ant currently is and the next city, and it can pick through all of the cities to determine where it's going to go next. But as the ant moves from point A to point B to point C, it actually deposits pheromones, virtual pheromones, on the edge that it travels. And once you start talking about edges, we're getting into a graph algorithm and some more sophisticated computer science terminology. Effectively, you have your virtual ants depositing virtual pheromones on these edges, and you can now use the amount of pheromone on each trail to determine the next path. You continue to repeat this pattern by having multiple virtual ants dropped at all these different random points, deposit pheromone on the virtual edges, and use the amount of pheromone left over by that population of ants, maybe 5 or 6 ants, for another round where you have, again, virtual ants travel the same cities, different paths, using both distance and quantity of pheromone on the edge between where it is in the next city to rate the attractiveness. And as you start working through this, you can start to see a solution kind of become apparent. So you start with generation 1, an ant travels around randomly. The second component here is showing all of the different paths that ants have traveled. And the third one is showing the paths that have the heaviest amount of pheromone, which then takes us to the fourth graphic, which shows us a much more optimal path than the random path selected for the first. Again, ant colony optimization is something like genetic algorithms that you can use to optimize logistics and supply chain questions, as well as manufacturing questions, solving the knapsack problem for how you're going to actually load certain things into a knapsack or into a box. But this can also be used to determine network topography. If you're dealing with any sort of networking, computer communication, trying to determine the best path to go from point A to point B to point C for communications, telecommunications, or just computer protocols, using perhaps maybe the RAFT protocol to establish consensus among multiple servers in a fleet. Any sort of network communication or any sort of thing where you're dealing with geospatially separated nodes and you need to identify the most optimum path to reach all of those geospatially separated nodes is a really good candidate for something like ant colony optimization or genetic algorithms. But again, machine learning here is just using a biological analog to determine something that we want to do in the computer world, because computers are the opposite of biology. They are very fixed, they are very, very static, they are very boring. And biology is very squishy, very flexible, and can come up with solutions that might take forever or just be fundamentally impossible for a computer to figure out on its own without this additional sense of randomness and this additional sense of biological evolution. So now that you have a little bit more of a basis in machine learning itself, let's talk about how we can take machine learning and principles of AI and apply it directly to WordPress. Now, if you're like me, you probably use WordPress mostly to produce content, specifically text content. One of the things that is tricky to do in WordPress is identify what are the topics of an article that you're writing, especially if you're anything like me and you write typically free form. You start with an article and you just write stream of consciousness and then try to optimize your SEO to get more eyes on the page after the fact. You can actually use machine learning to help optimize that. So for example, this paragraph about photography is one that's actually one of the stock examples for the Amazon Comprehend AI library. So Amazon Comprehend is a system that can pull out key phrases, perform sentiment analysis, identify entities in specific pieces of content, and actually do much more. It's incredibly useful in the medical community. It's also useful in the blogging community because Amazon Comprehend can look at a paragraph like this and then extract all of the, pardon me, all of the different key phrases that exist in this article. These key phrases can be used to highlight and focus search engine optimization and better direct traffic to this site, or even be used to better categorize your content and help other folks find related content that they need to based on search queries. Some other tools that Amazon provides are things like Amazon Recognition. Amazon Comprehend does text. Amazon Recognition does the same thing for images that Comprehend does for text. So if you give Amazon Recognition a photograph of a cycler, it will actually use computer vision to identify the different elements in that graphic and tell you with what confidence these different categories, tags, or just content elements exist in the image. You can use Amazon Recognition for automatic labeling, specifically entity detection. You can also use it for text extraction, OCR, optical character recognition. So you can use Amazon Recognition to scan, for example, a photograph of a book or a photograph where people have a bunch of text written on t-shirts, and it will identify what that text actually says and make these photos now searchable in terms of text. Now, those are a couple of Amazon tools that I'm speaking about much more in the abstract, because while you can use them with WordPress, there aren't a whole lot of tools that are out there today that make it really easy to integrate these tools with WordPress. The APIs are available. They're freely documented. Even though you do have to pay for the service, the Amazon libraries and APIs make everything incredibly accessible for you to integrate this into your WordPress site directly. But if you don't want to build it yourself, it's really cool that a company called 10up has actually created a plugin called Classify AI, yeah, just a really fun play on things, which integrates many of these tools already directly into WordPress itself. So Classify doesn't actually use Amazon. I personally am a big fan of Amazon and the way that they do AWS and do their web services, but Classify actually uses a couple of other cloud providers. Specifically, it uses Azure, which is Microsoft's machine learning cloud platform, and IBM Watson. Just like Amazon, both Azure and IBM Watson have free tiers, so you don't have to pay for a full account if you just want to get started, and it gives you the ability to experiment. Like WordPress itself, Classify is completely free. You can register whenever you want and just start playing with it, pull in the free tiers of both Azure and IBM Watson, and then you're off to the races and you can start integrating all of your content and integrate your site with it as much as you want. But let's talk about some of what it actually does. And let me give you a really quick example. So this is a screenshot of an article I was actually writing in WordPress titled Storytelling. And it was talking specifically about different angles that you can use for marketing to tell the story of a product, tell the story of a business, or tell the story of a service that you're actually working on with your product. When I wrote this article, I didn't categorize it. Well, I categorized it as business, but I didn't pull out keywords. I didn't do sentiment analysis. I didn't pull anything else. So I just took this article in WordPress and then I threw it at IBM Watson, specifically IBM Watson's natural language processing mechanisms, which is buried into Classify. So you give Classify an API key, and when you write an article and you click save, Classify will send the article, the content, your text, to IBM Watson's natural language processing unit, and IBM Watson will come back and tell you what it thinks the categories are, what it thinks the keywords are, if there are any entities. So if you started talking about Apple, Microsoft, Google, it will tell you what those different entities are, and you can tag the post accordingly. For example, after I threw this article at IBM Watson, it came back and told me you have business and industrial, business operations, children, education, homework and study tips, management. There's quite a few categories that this actually threw back at me. And you can tune the system up and down as much as you want. I had the sensitivity set at a default 70% chance that the category was actually relevant to the article. Using this production, I would set that threshold to be much higher because this article is very much about marketing a business, not really about family and parenting or children. Those are kind of false positive hits, specifically because one of the anecdotes I tell in the story is about a college professor who was talking about family, and IBM Watson just picked up on those terms. Now, this worked as I was writing the article, and when I saved the article, it automatically recommended these categories. But in many cases, you have a huge body of content that you haven't run through these machine learning tools. The cool thing is Classify gives you the ability to do this in like an ad hoc on-demand mechanism. So here's the example from my test bed where I had my storytelling article, which has now been fully categorized, and it's got the concepts that were drawn from the article. But the Hello World article, the default article in WordPress, is not categorized by Watson. It hasn't been pulled into concepts by Watson. So there is now a Classify button or a Classify link on the article. And if you click that, this will on demand resend the article to IBM Watson and allow you to dynamically reclassify that article automatically, telling us now that Hello World is talking about internet technology, social network, and it should be in the computer programming, newspaper, publishing, and film editing concepts. Now, again, this is the default Hello World article. This is your first article, start publishing content. It's incredibly basic, but Watson is able to pull out what it's actually talking about. Hello World itself is a common computer science topic, which is where computer programming comes from. This is your first article. There you go, newspaper, start publishing. Everything fits. And IBM Watson was able to extract all of that from the content. Now, again, I mentioned Classify is an open source plugin. It's produced by 10up. which is an agency that operates in the WordPress space. There are some fantastic engineers over there, and they put a lot of work into this plugin. And the text generation and the text filtering is not the only thing this plugin is capable of. IBM Watson works by pushing the content. So you push the content to the natural language processing unit and you get results back. Azure is actually used for image manipulation, but the computer vision components of Azure operate on a pull basis. So instead of uploading your image to Microsoft Azure, you tell Microsoft Azure an image is available, and Azure will pull the image in, process it, and then trigger a callback to give you information about that image back on the other side. So in that case, Azure's computer vision component will allow you to dynamically generate descriptions of images, and it will use the computer vision to determine what the image is about and populate your alt tags for you. In addition, smart cropping allows the computer to determine what is the actual focus point of an image. Where should we crop? If you are taking images on your phone, you are dealing with rectangular images. By default, the system will crop to the center. In some cases, that will work just fine. In other cases, you might have taken a photo of a person with a huge mountain behind them or in front of a Christmas tree or a statue. And cropping right in the middle is going to cut off both the statue in the background and the person in the foreground. With Smart Crop, the computer vision component will identify where's the focal point of the image, and it will actually shift the cropping boundary to make sure that the focus point of the cropped image, or the focus point of the full-size image, remains the focal point of the cropped image as well. And just like creating dynamic image descriptions, Azure Computer Vision will generate tags based on the entities that are present in the photo. And then you can use that inside the media library in WordPress to automatically group images together, which just drastically simplifies the way that you can manage your media library. All of these are built into Classify today, but again, Classify is open source. Everything is done publicly on GitHub. The entire code base is open, and you can extend it as much as you want. They've already started baking in support for AWS recognition as well as an alternative to Azure Computer Vision. It's just an extension that I haven't experimented with on my own, so I can't talk too much about today, but the code is there, and it is on the roadmap to have full AWS support as well. So now that we've talked a little bit about machine learning, what machine learning is, and how you can integrate with that with WordPress, I really hope everybody is going to go out and start actually seeing that machine learning and AI is not the nefarious future that we've been sold by the movies, by various different media components. It's not all about the end of the world. The T-1000 is not coming. Judgment Day is not going to happen in terms of Terminator 2. But AI is accessible today. It is something we can use today. You don't need a PhD to leverage it. You don't need to be a sci-fi junkie to use it. You don't even need to understand the algorithms or the math that goes into it, because all of the APIs abstract that away and allow you to just actually use it to produce value for your business and value for your content. It's something I would highly advocate anybody get started with today, and it's available. It's just up to you for when you want to dig in. So thank you very much. For those of you who don't know me, my name is Eric Mann. I am a director of engineering at a company called Vacasa on the west coast of the US. We do vacation rental management, and I run various tech teams for the organization. But I also have a very fond place in my heart for WordPress, as that was how I got started in the community. And I use WordPress quite frequently and try to marry all of the newer technologies and newer techniques that I'm working with to my love of WordPress and the WordPress community as well. So if anybody ever has any questions, feel free to reach out to me. My email's on the screen. That phone number will get to me eventually, so feel free to reach out. But we do have time now for the handful of folks who are on here if anybody does have any direct questions today.
I'm not running the sound, so anybody who wants to can unmute and ask your question.
Yeah, so I'm curious, Eric, when you're showing just the kind of the example of it connecting to kind of highlight keywords, I noticed it had like Watson category, Watson tag. So does does the plugin provide its own taxonomies, or is that, or you specify the taxonomies that you want it to provide?
The
keywords
plugin
for?
by default provides its own taxonomies in case you don't have them, but you do have the ability to actually toggle what taxonomy it filters into. So if you want to use classify to just populate your default categories and tags, you can actually do that. That's in the settings. You can control that. But by default, the plugin doesn't force you to do that in case you don't want to accidentally overwrite carefully handcrafted categories and you want to use Watson as a suggestion, as an email augmentation of your editorial process.
Gotcha.
Does it work with custom post types?
I've only tested it with posts and pages, so I'm not sure off the top of my head. I pretty vanilla WordPress installs, to be perfectly honest.
Yeah. I'm 7 years into HeroPress now, and the default essays do not have a categorization at all. They're all just plain because they're all written by different people on completely different topics, and I never tried to silo them. But I can see where it could be useful to have some sort of categorization, and this sounds like a good way to do that.
Yeah, absolutely agree. I was just going to take a quick look at the code to see if it does work with custom post types. Yeah.
How much did you try out, or did you try out the smart focal point cropping?
I played with it a little bit. So it's image cropping kind of has pros and cons, where sometimes it works really well, sometimes it doesn't. Anybody who's paid attention to Twitter over the past few years saw that someone put together, because Twitter also uses smart focal point cropping as well, and somebody put together a really long image that had I think it was Mitch McConnell at the top and Barack Obama at the bottom, and it would always smart crop around Mitch McConnell. So they figured maybe it just defaulted to the top, and they flipped it and then still cropped to the bottom on Mitch McConnell. And it turned out it was just the AI model had been trained with white faces and was ignoring the fact that Barack Obama was in the picture entirely and just cropping on Mitch McConnell. So some of the machine learning models will have bias based on the training sets that were actually applied, but they are a good starting point. And they typically will deal with like the 80% use case. And if you find yourself in that 20% where it doesn't really fit, then that's the point where you want to start working with a data scientist or somebody who can help train a custom bespoke version of the same model for you.
Gotcha. Okay. Yeah, like focal point cropping has been a major pain point that we've had just within WordPress. Like there's very few plugins out there that do that, and some of them that have been around, they don't, like, there's just bugs that they just don't work very well. And so I saw this, I'm like, ooh, could this be a helpful potential solution on the forefront for us?
It does look like the Watson classifier will classify custom post types as well.
Nice. Good. Eric, are you familiar with the plugin My Eyes Are Up Here? And do you know if it uses Azure or some other tool?
I have not seen that.
Okay. It's focal point cropping. By default, it looks for eyes. And so if there's a person, like a tall, thin picture of a person standing, the WordPress thumbnail will not be their abdomen. It will actually be their head and shoulders. But you can arbitrarily also, like, you just pull up an image and click on it and say, this is where I want my focus to be. And it will crop around that. So, you know, you can get a picture of the mountain instead of the lake or whatever. And I've never looked inside. I don't know how it works. It blows my mind that anything can be that smart to look for eyes in a picture in PHP. But now that you've mentioned Azure, it makes me wonder if it's using some service.
It looks like it's actually using a jQuery plugin to do face detection rather than doing it on the PHP.
Okay, that still is pretty amazing to me.
Yeah, but it does not look like it's using Azure or anything like that.
Okay. I can't imagine doing like facial recognition in jQuery. All right. Any other questions?
Yeah, I was curious. Eric, what was your sense of like the performance of like the interaction and like what's like, something getting submitted to one of the AI engines and the return back on that?
Yeah, the content stuff, so the things going into IBM Watson were actually pretty fast. So that was remarkably fast, but that's also text. Text is relatively small when we're talking in terms of the internet. So it's really just limited based on the server bandwidth, really. So if you're doing this locally, it's going to be significantly slower than if you're doing this on a server with a really wide pipe to the rest of the internet. The image processing, that one's a little bit trickier. And that's one of the reasons why it takes a pull approach rather than a push approach. Because if you want to upload an image and then wait for the image to now stream to another service, be classified, and get that information back, it will make the media gallery just feel that much more sluggish. So in that case, it's using a much more asynchronous method to make it much more performant under the hood.
The media gallery never feels sluggish.
So I just did a quick scan, and the face detection plugin used by that My Eyes Are Up Here plugin, it appears to be using what's called a convolutional neural network under the hood.
Okay.
And a convolutional neural network is a technique where you take an image and then you apply a bunch of filters and transformations to it. And then you use all of these filters and transformations to then feed into a neural network to do detection. And this is, if you've ever seen like detect edges in Photoshop.
Yep. Yep.
That's how that works, is by using different masks to actually manipulate the image until it can detect the edges and highlight those. And it's doing the same thing, but very specifically coded for eye detection.
Okay.
I just scrolled through quickly. They're not doing it dynamically, so they're definitely using a pre-trained model. But the first 16,000 lines of the jQuery.facedetection file are literally all of the matrix transforms to do all of that work for you.
Wow. I can't imagine writing stuff. You gotta really want it.
Say, Eric, how much through the paces did you put like IBM Watson in terms of like, I'm just thinking about if the block editor gets very complicated with various types of blocks versus, something more simple like paragraphs.
I didn't put it through too many paces, but what happens is basically the on save, it converts it to the text output strips tags, and then just sends effectively the text output. So depending on how complicated you get, it's effectively doing a HTML to text conversion before it sends that over to Watson.
Gotcha. So essentially, it doesn't know anything about like headers or headings and like how those could be potentially like prioritizing your content.
No, there's the mechanism to potentially weight those in the future, but it does not appear to be doing that today. And there are quite a few other libraries out there. So Watson is one. Azure actually has its own natural language processing as well. Amazon, I pointed out, Amazon Comprehend is pretty adequate. There's also another one out there called MonkeyLearn. MonkeyLearn is also a free API, and that also does categorization, and it uses a bunch of pre-trained models based on blogging. They literally ingested anybody who has a blog over like the past 5 years and use that to train a model to do content recognition and content categorization as well. And they're a pretty inexpensive API. There are quite a few different options that are out there.
Okay, cool.